Now let's look at definite integrals or definite integration. So what are definite integrals? So far after integrating, we had to put a constant of integration because we do not know what the constant is. Such integrals are known as indefinite integrals. However, if we are given the boundary condition, we can always evaluate a single value for the integral. That makes it a definite integral. So what do I mean by that? When we have been solving indefinite integrals, we just differentiated and we had a constant and we had an expression plus a constant of integration. But when we are talking about definite integrals, we will usually be given a boundary condition, and based on those boundary conditions, we can get a singular numerical value to define a value for the integral. And here's what I mean. So in definite integrals, the boundary conditions are given as the upper and lower limit on the integral sign. So for a definite integral, when you have the integration symbol over here, you have a value at the top b and a value at the bottom a. The value at the top tells us the upper limit of integration, while the bottom value a gives us the lower limit of integration. The function that we are trying to integrate is called the integrand, and the x is the variable of integration, or in other terms, what the variable that we are integrating with respect to. So how do we go about solving this? So the first thing we have to do is we have to try to integrate the function like we normally do. And when we integrate the function normally, then we now apply or we fix in the boundary conditions and evaluate the upper limit minus the lower limit. I'm sure that this might look abstract to you, but the following example will illustrate what I mean exactly. So in this simple example, we are told to integrate x squared dx with what boundary conditions from 2 to 1. So how do we do this? We first integrate this normally, and when we integrate this normally, what do I have? X squared becomes x raised power 2 plus 1 over 2 plus 1 plus my constant of integration. I'm integrating from 1 to 2. So this becomes what? X raised power 3 over 3 plus my constant, my boundary conditions are 2 and 1. So now what does the formula tell us? It says to solve it, what we have to do is just to evaluate the upper limit minus the lower limit. So what does this mean? What it means is that the value in the upper limit or the boundary condition, the upper boundary condition, which is 2, we substitute it for the value of x and we try to simplify it. So that is how we get the upper limit. So the upper limit in this case becomes anything or any place where you see x, you replace by 2. So that becomes what? 2 raised power 3 over 3 plus c. Then my lower limit or my lower conditions become anywhere you see x now, I replace it for the value of 1. And that becomes what? 1 cube over 3 plus c. Then I just subtract this. So what does that become? 2 raised power 3 is 8 over 3 plus c. This becomes minus 1 over 3 minus c. Minus c plus c cancels out. I'm left with 8 over 3 minus 1 over 3, which gives me 7 over 3. So now there's something important for you to note. You can see that when I integrated and I applied the boundary conditions, the constants cancel out each other. So what this tells us is that when we are solving questions or questions that have to do with definite integrals, we do not need to put in the constant of integration, because we know that when we are subtracting the upper and lower limit from each other, we know that they are going to be cancelled out. So to work this out properly, we just say that the integral of x squared from 2 to 1 is given as x squared becomes x cubed over 3. There is no need to include the constant of integration because I know it will cancel out. Then from 2 to 1, so this becomes, I replace 2x as 2, so this becomes 2 cubed over 3. Then minus, I replace 1 as x, 1 cubed over 3, which definitely results in what? 7 over 3. So let's move on to another example. And in this example, we are told to evaluate this expression over here. So the same thing applies, very straightforward and very simple to do. So what do? I integrate all these expressions here normally. So what does this become? This becomes what? X cubed becomes x raised power 3 plus 1, which gives me x raised power 4 over 4. Then this becomes minus 2x. I have x raised power 1 plus 1 becomes x raised power 2 over 2. Then my 1 becomes what? When I integrate 1, I get what? I get just x. So that becomes plus x. And as mentioned, when I'm integrating definite integrals, I do not need to add my constant of integration because I know that they are going to cancel out. So I integrate between the boundary conditions of 2 and 1. So when I simplify this is same as having what? X raised power 4 over 4 minus x squared, because 2 cancels out my 2, then plus x, then 2 and 1. So what do I have to do now? I have to just do my upper limit minus my lower limit. So that becomes, my upper limit becomes what? I put x value as 2 first. So that gives me 2 raised power 4 over 4. Then minus x becomes 2 again. Minus 2 squared. And this x becomes 2 plus 2. Then minus my lower limit. In this case, I put my x value as 1. So I have what? 1 over 4. Then this becomes what? Minus 1. And this becomes what? Minus 1 squared. And this becomes what? Plus 1. So very straightforward. And what do we have? This becomes what? 2 to the power of 4 is 16 over 4. 16 divided by 4 is 4. Minus 2 squared is 4. Then I have plus 2. Then I have minus. I have 1 over 4. 1 squared is 1. Minus 1 plus 1 is, so I have 1 over 4 minus 1 plus 1. So does that become 4 minus 4 gives me 0. So I'm left with 2 here minus, and minus 1 plus 1 gives me 0, minus 1 over 4. And that gives me what? 7 over 4. So when you integrate this expression from boundary conditions from 1 to 2, you get the value to be what? 7 over 4. And as you can see, this represents a single numerical value, and that is why it is called a definite integral. Now let's move on to the last example. And in this example, we are told to evaluate the integral of x sine x dx. So without making much time, to integrate this function, as we've discussed before, we have to use integration by parts, and based on the example that we solved, which is also equal to this, we can just write out the result we got before. And what was that result? We got the integral of x sine x to be equal to minus x cos x plus sine x. And as I've said, there is no need to include the constant because they are going to cancel out. So I'm integrating from pi over 4 to 0. So for my upper limit now, so I have what? My upper limit minus my lower limit. So for my upper limit now, I replace the value of x as pi over 4. So that becomes what? Minus pi over 4 times cos pi over 4. Then plus sine pi over 4. Then minus my lower limit, I put x as 0. Minus 0 cos 0 plus sine 0. So now how do we evaluate this? First, you have to know what pi over 4 means. Now if you remember our discussion on trigonometry, I mentioned somewhere there that when you have pi and you're talking about angles, this is definitely talking about angles in radians. And I told you that pi is in radians is the same thing as having what? 180 degrees. So pi over 4 will just be 180 over 4, and that is the same thing as what? 90 degrees. So if you punch in your calculator and you put it in radians and try to evaluate the value of cos pi over 4, the same thing as finding the value of 180 over 4 gives me 45 and not 90. So if I try to evaluate cos pi over 4, I'm going to get root 2 over 2, which is the same thing as finding cos 45. So what does this give me? So now I know that cos pi over 4 is same thing as cos 45 is equals to root 2 over 2. Similarly, sin pi over 4 is same thing as sin 45 in degrees, which is the same thing as what? Root 2 over 2. So I can substitute all that here. So this becomes minus pi over 4, and this becomes what? Times root 2 over 2, and sin pi over 4 is what? Root 2 over 2. Then minus, cos 0 is 1, 1 times 0 is 0, sin 0 is 0, so I have minus 0. So what is common to both terms? Root 2 over 2 is common, so I have root 2 over 2 into bracket minus pi over 4, then minus 1. So this pretty much sums it up. So you can try to punch in your calculator and try to simplify this, but I'm going to stop right here. So you get the general idea. So what we did again was we first integrated what? The function, and when we did that, we applied the boundary conditions by first fixing in the upper limit, which we did over here, and we fixed in the lower limit. But now we have to deal with radians, angle in radians. I know that pi over 4 is same thing as 45 degrees, and cos 45 degrees is root 2 over 2, same as sin 45 degrees. So we apply that to simplify this and this, and we just simplified further to get this. So this pretty much sums up definite integrals. So if there is one thing to remember as regards to definite integrals, is that when you're solving definite integrals, you are going to get a single numerical value as a result, whereas when you are solving indefinite integrals, you are going to get a function plus, or an expression plus your constant of integration. So this pretty much sums up our discussion on integration, and what we've discussed is what you need to know to be able to tackle JAMB questions specifically. If you are planning to write the WAEC or to take other exams, you may need to expand your ideas. For the purposes of JAMB, this is all you need to know. So now in the next session, we are going to be looking at some of the applications of integration.